Now, let's talk about your test that I'm about to pass back. Again, it'll be towards the end of class because I want people to focus on up here. But here was the overall grade distribution of the class. Class average on the test was a 72. I'm not real thrilled with that. Now, you guys have got to do better. But here's the problem that I had more than the average of 72. I had lots of folks in here make A's on this test. I mean, just literally blew it out of the water. Very impressed. I had like 4 100s, so forth and so on, lots of 90s and things like that. But if I got lots of 90s and high 80s and things like that, and I got a class average of a 72, what's that also telling you? I've also have a large number of folks that aren't studying this stuff and are getting caught cold. And basically they embarrass themselves on this test and end up not doing as well as they should have on it as compared to everybody else. And I want to remind you guys, this is college. It's all about competition. I know that math is not as enjoyable for some people as it is for others, but nevertheless, just like I had to go through, pass all my Englishes and as a math major, you guys have got to pass all your math classes if you're not studying. Now, don't get me wrong. I've got some people who are doing absolutely superb in here. And I got folks in here who are already in chapter 4.1 trying to do the pre-section quizzes on 4.1. I mean, I hadn't even set up chapter 4.1 stuff yet, and they're already up there. I'm very impressed by that fact, and I got it done quickly, and I got it all chapter 4 set up for you guys. But nevertheless, you still got lots of time to pull up your grades, but you got to pull up your grades if one of your people, especially if you made below that 72 average, I'm talking to you. You've got some time, but you can't let this stuff get away from you. I know there's a lot of work to be done. You've got pre-section quizzes, you got the homework from each section you got to do. You have my homework just before a test. You got big test. Also, to let you guys know, remember that there's another component to this test, which was your web test thing, and most folks did very well on that, and that's going to help pull up your grade too. But I'm not talking about that. I'm just talking about this particular test. If you didn't do as well as you should have, well, then next time, make sure you do a lot better on it because you got to pull up your average and stuff. And it's still doable, but you got to put the effort into this thing. You know, I'm in my office hours, and don't get me wrong, I teach Calc 1 and Calc 2, and I also help out a bunch of other different students, differential equations, linear algebra, graduate students, and all this other stuff. But you know what? Out of 120 people I got in this class, you know how many people have actually come by and seen me about it? About 5. Yeah, not very many. And that tells me you're not taking it seriously, because if you need this stuff, you come by and see me. You come by and see Andrew. We also have Friday sessions just available for you guys, just to help you guys out. Also, there's SI sessions. There's also Fretwell 315 open tutoring. If you got a question, go in and see them. But you got to make the effort to go out of your way to get this stuff done. All right. Today, I plan on doing a big thing today, a very important section, because it has a lot of overtones for future math classes. And that is section 3.3, 3.4, and if I'm lucky, I'll probably start 3.6. We're omitting 3.5. So we're talking about lines. Now, I know you guys have done lines many times before, but I'm going to lay it out to you as in the most distinct and direct fashion as I can. When to use what and why. So, first off, we got to talk about, first thing to talk about lines, you got to talk about slope. You got the slope, the standard symbol for slope is the letter M. It's equal to, when you graph it, it's the classic rise over run. But as a formula, it is y2 minus y1 over x2 minus x1, where you have two different points. You got your first point, x1 comma y1, and you got your second point, x2 comma y2. So it's the change in y's over the change in x. y2 minus y1 divided by x2 minus x1. Also, for mathematical symbols, change in mathematics is a symbol delta. It is delta y over delta x, or change in y over the change in x. Just be consistent on your order. Second point, first point, y2 minus y1 over x2 minus x1. The purpose of the slope is to tell you something about your line. If your slope is greater than 0, a positive slope, you read a graph from left to right. That means the slope from left to right is actually increasing or going up as you read it from left to right. If the slope is negative, number less than 0, the slope is decreasing as you read it from left to right. The slope is going down. You always read from left to right when it comes to graphs. If you have a slope of equal to 0, that's considered a no slope, and the slope is considered 0. M equals 0, it's a horizontal line. And there's one other way you can actually have a slope, and that is undefined. You get an undefined slope when you try to calculate the slope, and you get like 5 divided by 0. You can't divide by 0, so we define that as an undefined slope, which makes vertical lines, lines that go up and down. So slope equals 0 is horizontal, slope undefined is vertical. And then you read it from left to right, positive slope, it increases, it goes up from left to right, and a slope that's negative has this decreasing slope. As you read it from left to right, it goes down. So find the slope connecting these 2 points. The trick is, it doesn't matter what order you put them in, just be consistent on that order. I got 3, -2, and 4 and 5. I'll call this x1, y1, x2, y2. So my slope is going to be change in y over the change in x. So that would be y2 minus y1 over x2 minus x1. That'll be 5 minus -2, watch your signs and watch the careless errors, divided by x2 minus x1, 4 minus 3. 5 minus -2, question? Sure. 5 minus -2. What's minus a minus? Positive. So that makes it 7 over 4 minus 3 is 1, and 7 divided by 1 is 7. This tells me that I have a slope of 7, which as being positive, I know this line is going to be increasing as I read it from left to right. What about this point? 8, -4, and 5, 2. So again, labeling my points, x1, y1, my first point, and x2, y2, my second point. My slope is change in y over change in x, y2 minus y1 over x2 minus x1. Plugging my numbers in, y2 is 2, minus y1 is -4, divided by x2, which is 5, minus x1, which is 8. So now all I got to do is clean it up. A minus makes it a plus, and 2 plus 4 is 6, divided by 5 minus 8. 5 minus 8 is what? -3, so I reduce my fraction there. 6 divided by -3 is -2. I have a slope of -2. Over here, my slope was 7, which means it was an increasing slope. Here, my slope is -2, which tells me I have a decreasing slope. Does that make sense? Now, let's talk about lines for a second. Determine the slope and y-intercept for each linear equation. Now, this is something very important, and in terms of equations of lines, it's the form that most people remember when it comes to equation of lines. The equation of line that they're trying to get it in terms of is something called the slope-intercept form. What is the slope-intercept form? You guys know it better as what?
Y equals mx plus b.
Very good. Y equals mx plus b. Now here's the deal. M is the slope. It's the coefficient in front of the x. B is the constant being added or subtracted, and the constant is your y-intercept, or the place that crosses the y-axis. You know, and when they ask for the y-intercept, you can give them the b number, but a lot of the times they want it as an ordered pair. The ordered pair is x equals 0. When you do a y-intercept, x equals 0, and then you get your y number. So, to be able to get the slope in the y-intercept, you've got to put it in this form. And this is where most students will screw this problem up. I'll give you this equation. 12x minus 4y equals -9. And I ask you, what is the slope and what is the y-intercept? And I will have students that will tell me the slope is 12 and the y-intercept is -9. And they screwed it up. The reason why they screwed it up is because, one, they got lazy. The fact is, you can't just read off coefficients off a line and expect that to be the answer. You've got to put it in the correct form. The form of figuring out the slope and the y-intercept is you've got to solve the equation for y. How would you solve for y on this thing? What's your first move? I would subtract 12x from both sides. That gives me negative 4y equals negative 12x minus 9. What's my next move to solve for y? I would divide by negative 4. What I do to one side, I do to the other. What I do to one term, I do to all terms. I'm dividing each term by negative 4. Terms are separated by addition and subtraction. The negative 4's cancel over here, leaving me with y equals, what is negative 12 divided by negative 4? Positive 3x. What is a negative 9 divided by a negative 4? Negative divided by negative is a positive, plus 9/4. So, I've got it written in the form of y equals mx plus b. So now you can read off the data. What is my slope? My slope is my coefficient in front of the x, which is 3. The y-intercept is b. What is my b? My constant that's being added to this mx. What is it? 9/4. And sometimes they just ask for b, or another way they could ask for it is the point. The point for the y-intercept would be x equals 0, y is the 9/4. You can write it either as an ordered pair, 0, 9/4, or sometimes ask for what's the y-intercept b, and you just give them the number, 9/4. They will be specific on the questions, and I will be on any kind of weird test or homework. Does that make sense? Now, let's try b over here. I got the equation 4y equals 12. To find the slope-intercept form, you always want to solve for y. But this one's real easy to solve for y. What you going to do? Divide by 4. But there seems to be no x on this side. When I solve for y, I get y equals 12 divided by 4, which is 3. There's my equation. Y equals 3. So what's the slope? The slope is the coefficient in front of the x. But here's the deal. Where is there an x at? There is no x. So what must be the coefficient in front of the x if the x doesn't show up?
0.
This would be a slope of 0. And your constant b, which is your y-intercept, would be what? 3. Or you can say the y-intercept point is the point 0, 3. Because you could write this as y equals 0x plus 3 if you wanted to put it in the original y equals mx plus b form. But if there is no coefficient of x, then the slope has to be 0. If you ever have a line x equals 27, x equals, and that's all you got, that means the slope is undefined because you can't even solve it for y because there is no y to solve for. That means the slope is undefined. So let's try c down here. I have 4x minus 2 equals x plus 10. Your mission, find the slope and y-intercept. Here's the deal. When I want to find the slope, I always want to put my lines in y equals mx plus b form. There is no y's on this equation. That's what I was just talking about. There are no y's. What do you have? X. Well, let's at least solve that variable then. So if I'm going to subtract x from both sides, that gives me, that cancels there. 4x minus x is 3x, minus 2 equals 10. I'm going to add 2 to both sides. That gives me 3x equals 12. I'm going to divide by 3, and that gives me x equals 4. But this one is something you should recognize. X equals a number is what kind of a line? It's a vertical line. Here is x is 4 on the x-axis, and it makes a vertical line. And on a vertical line, what is my slope? Undefined. And what is the b, the y-intercept? What point are we actually crossing the y-axis? We're actually parallel to the y-axis, which means we never cross it, which means it is also undefined. Does not exist, no solution, however you want to put it. There is no y-intercept because you can't solve for y, therefore there is no slope, there is no y-intercept. It's a vertical line. Does that make sense? Something to look for when they try to trick you into this kind of a problem, because this is a trick question. If there is no y's, you just completely blow it off, solve for the variable that you can. But if the only variable is x, there is no slope, or excuse me, the slope is undefined, and the y-intercept is undefined. And let's go for something a little bigger there. let's try this one. 2y minus 7x equals 4y plus 5x. Find the slope and y-intercept, same directions. For the slope and y-intercept, I want to make sure that I put it in the y equals mx plus b format. So I'm going to solve this thing for y. To solve it for y, I'm going to subtract 4y from both sides. This cancels on the right. 2y minus 4y is a negative 2y minus 7x equals 5x. I'm going to add 7x to both sides. The 7x is canceled. That leaves me with negative 2y is equal to 5x plus 7x is 12x. And then the last thing I'm going to do is divide by negative 2 on both sides. And this is going to give me y equals 12 divided by negative 2 is negative 6x. And there is my equation of a line. Remember, the slope is the coefficient in front of the x. What's my coefficient in front of my x? Negative 6. B, the y-intercept, is the constant that's being added. What constant is being added to this thing? Nothing, so it's 0. So in other words, my slope is negative 6, which tells me that it's decreasing as I read it from left to right. And the y-intercept, if I want it as a point, remember, for y-intercept, x is always 0, and y, in this case, would also be 0. It goes to the origin, 0, 0. Bless you. Does that make sense? Okay, turn page. Now, here's the big deal. This is every possible line that you should know. When it comes to lines, I'm doing all of them at one time. There is the famous point slope form, and it depends on which one that you use, and there's a little typo here. This should not be a 2 there. Get rid of those guys. You get y minus y naught equals m times x minus x naught. And you can also have y minus y1 equals m times x minus x1. But with 2 points, you first find m. Got to find your slope. But here, let me explain it to you in better English than that. This is the one thing that your high school teachers, well, most of them, some of the good ones do, but most of them don't, is tell you when to use which type of an equation. There is the point slope formula, and here is the traditional point slope formula, but you know, they're trying to write it in 2 different ways, but there's 2 different scenarios you can use this. There is the slope intercept form, which we just talked about, the famous y equals mx plus b. There is the famous general form, ax plus by plus c equals 0. You have your horizontal line, y equals b, a constant. You have your vertical line, x equals c, a constant. There are 5 equations to a line. But here's the deal. When do I use each one? All right? All right. Now, out of all these forms, which is the most important? Which is the most important? Now, I can tell you which one they stressed in all your Algebra 1, Algebra 2, and high school stuff. But that's not the most important. You know the one they stressed in high school the most? Slope intercept form, y equals mx plus b. They just threw that one at you, beat you in the head with that. Y equals mx plus b. So when I ask my students in any class, whether it's differential equations, Calc 1, Calc 2, Calc 3, whatever, what's the equation of a line? Everybody says the same thing because you've been programmed, y equals mx plus b. It's a slope intercept form. And that's awesome, and you're right, but it's not the most important form. So here we go. Let me just turn the page over just for a second over here, because I'm going to describe to you the importance of each different type. Y minus y1 equals m times x minus x1. This is called the point slope formula. It is the most important. This is the most important equation of a line because it only has one purpose in life. And that one purpose is this. One purpose. When you hear the magic words, which 9 times out of 10, this is what they're going to give you. Find the equation of the line. This is your duty. When you hear those 6 magic words, find the equation of a line, that, and then they repeat a bunch of stuff to you guys, this is your duty. The point slope formula, y minus y1 equals m times x minus x1. You got to have two things to use a point slope formula. We're math people. Don't think too deep in how we come up with names for crap. It's called the point slope formula. You need two things. You know what you need? A point and a slope. You give me a point and a slope, or find a point and a slope, this is your guy. This finds the equation of a line. And the reason why this is the most important equation is because, like I said, 9 out of every 10 problems we give you guys in terms of finding lines will start out with the words, find the equation of a line that does something or other. And you know this is your guy. The second most important, so this is your top rank, number 1. The second most important line is the guy that you guys all remember, y equals mx plus b, which is the slope-intercept form. Slope-intercept form, y equals mx plus b. The slope-intercept form has two purposes in life. The first purpose is to, quote, read off data. The first purpose is to read off data. And the second purpose is to graph it. When I want to graph it, I want to solve for y. And when I solve for y, it puts it into the y equals mx plus b form. So an example, read off data. Y equals 3x plus 2. Read off the data.
Slope is 3, y-intercept 2.
You got it. And I'm off the page there, sorry. The quote, slope is 3 and the y-intercept is 2. You read off the data. And that's what we do when we want to, and that's what we were doing just a few seconds ago. The slope-intercept form allows us to read off data. The coefficient in front of the x is the slope, 3. The y-intercept, the place across the y-axis, is 2. And then, the other thing we use is to graph it. As you just mentioned, the slope is 3 and the y-intercept is 2. So I start with my point y-intercept, which is 2. 1, 2, put a little dot right there, 2. And then my slope is 3, but you may know it better as 3 over 1. And this is where I use my definition of slope, rise over run. So I've got a slope of 3, or 3 over 1. I'm going to rise 3, run 1. Rise 3, 1, 2, 3, run 1, put a dot. Or I could rise negative 3. That's down, 1, 2, 3. But then I have to run left, 1. And then I connect my dots. And all you need is pretty much a couple of points there to graph it, but 3 is even better. And there's my equation of a line. We use it for two reasons. We read off the data and we graph it. But here's the deal. 9 out of every 10 problems we tell you about lines, we start off with the words, find the equation of a line. You actually have to have the equation to be able to read off the data and to graph it. So when you hear the words, find the equation of a line, this is where you start, the point slope formula. The third most important line, which is probably the least important line, number 3 here, is the general form. What is the general form? ax plus by plus c equals 0, where a is a positive integer and b and c are integers. Integers are plus or minus whole numbers. So b and c could be plus or minus some kind of number, plus 3, minus 14, something like that, plus or minus, could be 0, who knows. But a has to be a positive integer, 3, 4, 17, something like that, positive integer. Now, as I mentioned, this is the general form. It only has one purpose in life. What is that one purpose in life? That one purpose in life is it looks good. That's the only purpose in life the general form has. It looks real good to pull everything to one side and set it equal to 0. So if I'm publishing some kind of paper or something like that for some mathematical journal and I got an equation of a line, I'm typically going to write in this fashion, where I would write the equation, 3x plus 2y plus 6 equals 0. It looks good to pull everything to one side and have my coefficients as nice whole numbers. Does that make sense? Or at least positive integers, that is. A would be a positive integer, B and C can be any kind of integer, positive or negative. Does that make sense? It looks good. It has no real purpose in life whatsoever, except it just looks good to print it up that way. So if you look back over here, let's see here, we just did a problem. Actually, let me do it this way. It was on this page over here. You know, this one was almost in general form. It was 12x minus 4y equals negative 9. To put it in general form, it would be 12x minus 4y plus 9 equals 0. It has no purpose in life except it looks good to pull everything on one side and set it equal to 0. Okay? There are two other equations of lines because there's 5 equations of lines, and these are special cases. Special case. We'll call this number 4. Y equals B is a horizontal line. Special case. Y equals B is a horizontal line, which means it runs from left to right. So if I have something like y equals 3, if I wanted to graph it, I go up to, on the y-axis 3, and I draw a horizontal line. And your other special case is special case number 5. X equals A is a vertical line. A vertical line would be, an example, x equals negative 1. I come over here to negative 1 on the x-axis, and I draw myself a vertical line. And what you have to remember is vertical lines have an undefined slope. A horizontal line has a 0 slope. Does that make sense? So again, there are 5 equations of lines. But what's the most important equation of a line? And this is the amazing thing, that most students don't know this, that the most important equation of a line is the point-slope form because it always answers the question, find the equation of a line. So, let's go back over here. Look at my quote examples. Let me blow it up for you guys in the back there. Here it is. It says this. Find the equation of a line. Look at those first 6 words. There it is. 9 times out of 10. And actually, I should probably increase my odds. 99 times out of 100. This is what the equations ask for. That passes through the points 0, negative 3 with slope negative 2. Well, anytime you hear the words find the equation of a line, what should you write down? Point slope formula, which is y minus y1 equals m times x minus x1. You've got to have 2 things to use the point slope formula. A point and a slope. What did they give you? They gave me a point, 0, negative 3, and they gave me a slope, negative 2. Plug it in. This is your x1, y1. This clearly m is your slope. So plug it in. I get y minus my y coordinate, negative 3, equals my slope, negative 2 times x minus 0. There is the equation of a line that passes through this point with this slope. Here's my problem with the slope-intercept form. It's not pretty. I got y minus negative 3 equals negative 2 parentheses x minus 0. It's not pretty. So to make it pretty, you can either put it in general form or slope-intercept form and read off the data and graph it. Tip 9, again, most questions they're going to ask in this class, they like it in slope-intercept form. So I'm going to solve this thing for y and put it in slope-intercept form. A minus a negative makes it plus, so this is y plus 3 equals negative 2x. X minus 0 is x. Then I'm going to subtract 3 from both sides. That cancels, and that leaves me with y equals negative 2x minus 3. There's the equation of a line. It looks a lot better, but this is in slope-intercept form. Be familiar with all your forms of lines. Does that make sense? Okay. But there's these special cases. When they give you a special case, the trick is to draw it, whether it's mentally or physically on a piece of paper. Here we go. Find the equation of a line that passes through the point 2, negative 4, and this is your special case. What's that? Undefined slope. So, which tells me if we're going to graph it, 2, negative 4. X is 2, y is negative 4. 1, 2, 3, 4. Here's negative 4. There's my point. There's the point, 2, negative 4. What does an undefined slope mean? What kind of line? That means it's a vertical line. Undefined slope is vertical line. Horizontal slope, horizontal line is a zero slope. So this is an undefined slope is telling you to make a vertical line. If you draw yourself a vertical line in this thing, vertical lines have the equation x equals. And what is x equal? What are you going through? X equals what? Positive 2. X equals positive 2. There's my line. And here's the deal. I didn't have to do all this graphing. When I hear the word undefined slope, I know it's x equals. When I have a zero slope, I know it's y equals. And here's your point, 2, negative 4. If I said undefined slope, just write down the equation, x equals 2. If I said the slope is equal to 0, the answer would be y equals negative 4. You just write down the coordinate and you're done. But if you get lost, draw a picture. You'll know it. Does that make sense? Take a look at number 5. This one's pretty classic here. Let me quote it again. Find the equation of a line that, here we go, passes through the points 3, negative 2, and 4, 5. Remember, the first words were find the equation of the line. When you hear those words, and it's not a special case of slope not existing or slope 0 type thing here, what am I going to write down every time? Point slope formula. Find the equation of line, point slope. Y minus y1 equals m times x minus x1. You've got to have two things. You've got to have a point and a slope. What did they give you in this problem? 2 points. They gave me 3, negative 2, and 4, 5. So I've got the point part covered. Put a big old check on that. The part I don't know is the slope. But they gave me 2 points. I can find the slope. So to find the slope, you've got to write down my slope formula. So yes, you have a lot of memorization to do. We don't give you this stuff. We expect you to have it memorized. What's the formula for slope? y2 minus y1 over. Very good. x2 minus x1. y2 minus y1 over x2 minus x1. So I'm going to declare this to be x1, y1, x2, y2. I'm going to plug it in. 5 minus negative 2, watch your signs, over x2, which is 4 minus 3. What's a minus a minus? Plus, so 5 plus 2 is 7 over 1, which gives me my slope is 7. But here's the thing. To find the equation of a line, I need a point and a slope. And I had to calculate the slope, but there she is, m equals 7. Now I need a point. I got 2 points. I got more than enough information. Which point should you use? Honestly, doesn't matter. You can use either one. Personally, I use that point. Why would I use the point 3, negative 2 versus the point 4, 5? Smaller numbers, less chance for me to screw this problem up. Either point will work. I'm going to let you know my personal thoughts on this. I'll use small numbers, that way I don't screw up the basic math. So here we go. Plug it in. Y minus the y coordinate, watch your sign, negative 2, equals my slope of 7 times x minus the x coordinate, 3. So literally, it's just plugging into the formula. Now I'm going to clean this guy up, because it really doesn't look good to put it in point slope form. So that'll be y plus 2 equals 7 times x minus 3. And let's say, just for kicks and giggles here, I want you to put this one in general form. The only time I ever put a line in general form is when somebody puts a gun to my head in the direction saying, put the line in general form. Because it's never used. It doesn't really have a serve a purpose if it looks good. So make this answer look good. How do I make it look good? First off, I'm going to distribute. This will be y plus 2 equals 7x minus 7 times 3 is 21. Now, remember what I said about the general form. It is ax plus by plus c equals 0. You want to pull it all on one side, but you got 2 options on pulling it on either side. You can either pull it all to the left, or you can pull it all to the right. Which way do you have to pull it to be able to get it in general form? Remember, A has to be a number greater than 0. You want the coefficient in front of the x to be positive. It's already on the right side, it's already positive. So I don't want to leave him, I want to leave him alone. Does that make sense? So I'm going to pull everything to the right because my 7 is already positive. If this was a negative 7, I would have pulled everything to the left and made it a positive 7. It's all about the x coefficient. Does that make sense? You pull it to whatever side makes it a positive integer. So I'm going to pull everything to the right. I'm going to subtract y from both sides, and I'm going to subtract 2, and I'm going to pull it down this way. This cancels. That leaves me with 0 equals 7x minus y, and now add your coefficients. What's minus 21 minus 2? Minus 23. And there is my form of my line in general form. And on your homework, Hawk system, they're going to ask you a straight up question. In general form, what is A? What would A be? 7. What would B be? Negative 1. And what does C got to have to be? Negative 23. Does that make sense? Sign goes with it. Did I lose you guys anywhere? Question. Yes, ma'am. Oh, no, no. I mean, I just went out of your way and I said, hey, put it in general form. So I could have asked it, put it in slope as an intercept form. Now, they're traditionally going to tell you what form they want the final solution in. That way it matches to the computer answer. But sometimes most times they'll ask for slope intercept form, but on occasion they'll ask you to put it in general form just to make them happy about it. Just put them whatever they want. Does that make sense though? Find the equation of a line that passes through the point 1, 3 with a slope of 0. Again, each one of these has the same directions. Find the equation of the line. So, you'll notice anytime you hear the word find the equation of a line, I'm using the point slope formula, unless it's a special case. This is not. Because they gave me a point, which is the negative 1, 3, and they gave me the slope, m equals 3. So y minus y1 equals m times x minus x1. The famous point slope form. The point, negative 1 is x1, 3 is y1. The slope is 3, so that'll be y minus your y coordinate, which is 3, equals my slope, 3 times x minus my x coordinate, negative 1. Where most students will screw this up, make careless errors, is they try to do too much stuff in their head. You'll notice when I'm using the point slope formula, I literally just plug in the numbers that I'm given into the thing. I don't worry about the negative, trying to make that into a plus until my next step. Because just one false move on this thing, you got triple negatives, is that back to negative, or is I had another negative, is that positive or negative? And then after a while you get confused, and just write it down and then go back later and clean it up. Take your time. This will be y minus 3 equals 3 times x minus a negative makes it plus 1. And let's say for this one I wanted it in slope-intercept form. Slope-intercept form, I would distribute the 3. That's y minus 3 equals 3x plus 3. Distributing my 3 here. And then I would add 3 to both sides. And I get my equation, y equals 3x plus 3 plus 3 is 6. And then I can be in slope-intercept form, I can read off the data. My slope is 3, my y-intercept is 6, or it's the point 0.06. Find the equation of the line that passes through these 2 points, 3, negative 2, and 4, 5. Well, anytime I hear the word find the equation of a line, did we just do that one?
Yeah, we have the same exact problem.
Really? Is it the same on your notes, or is my notes different than your notes? Same? Okay. Well, see other page, and we'll actually fix this up the next time we make up these notes. All right, fine. So we've already done that one. So let's do the next one then. Find the equation of a line that passes through the point 1, 8, and 5, 8. All right? 1, 8, and 5, 8. Here's the deal. Anytime you hear the word find the equation of a line, what are you gonna write down? And I'm trying to drum this into your head. What are you gonna write down? Point slope. Y minus y1 equals m times x minus x1. Okay? And I need two things. It's called the point slope. I need a point. I got 2 points. Got that part covered. I need the slope. The slope is y2 minus y1 over x2 minus x1. And I got my 2 points. I can find my slope. This is x1, this is y1, this is x2, y2. It'll be 8 minus 8 divided by 5 minus negative 1. 5 minus negative 1. We'll clean that up. So my slope is equal to 8 minus 8 divided by 5 minus negative makes it 5 plus 1. 8 minus 8 is 0 divided by 6. My question to you is this. What number is 0 divided by 6? 0 on top, it's 0. 0 on bottom is undefined. Does that make sense? So 0 on top is 0. I have a slope of 0. But that's all right. It's still a numerical value. I can plug it in here. Watch. This gives me, pick a point. I like this point right here because of the smaller numbers, that negative 1 smaller. It'll be y minus y1, which is 8, equals my slope of 0 times x minus my x-coordinate, negative 1. This is y minus 8 equals 0 times x plus 1, but who cares? What is 0 times anything? This is 0 equals y minus 8. So solving it for y, I would add 8 to both sides, and this would give me y equals 8. And y equals 8 is what kind of line? This is a horizontal line, which is not a big surprise. Horizontal line. And the reason why it's not a big surprise is because what was my slope? 0. Horizontal lines have 0 slope. And if you get in trouble, graph it. If I graph this thing, here's negative 1, here's 8, there's a point, here's the point 5, 8. There it is right there. And if you connect your dots, it makes a horizontal line right through 8, y equals 8. Yes, ma'am.
So when would you use the point slope form with the 2 points?
Typically, you don't. I mean, you can, but you don't have to. The point slope formula does everything for you. The only time I want to use the slope intercept form is to read off data. Okay? Now, granted, in that first problem, way back over here, this first problem that I did, see, I'm trying to, if this procedure works every time, I don't have to outthink the question. And that's what this line stuff is. But you see this one? Find the equation line that passes through the point 0, negative 3 with the slope of negative 2. 0, negative 3. What kind of point is that? Graph it. 0, negative 3. That's actually the y-intercept, isn't it? So with this one, the other way I could have done it was I can read 0, negative 3, that b would be negative 3. My m is negative 2. And then I could go straight for the y equals mx plus b form. And that'll be y equals negative 2x minus 3, which is exactly what I got. But you had to go out of your way to recognize the point 0, negative 3 they gave you was the y-intercept, which makes b equal to negative 3. But if I always use the point slope formula, I'll get the same answer. Every time you hear the words find the equation of a line, use the point slope formula. It'll give you the answer the same way every time. That's why it's the most important equation of a line. But don't get me wrong, the slope-intercept form is important. But it's important in two aspects. You use the slope-intercept form to graph and to read off data. Take a look at this particular question here. Use the point slope to graph each line, because this is the equation that I have to use to be able to graph. Y equals mx plus b. I start with the b, the y-intercept, that's the place it crosses the y-axis, and then I calculate my slope, I read it off, and then I do the rise over run bit. So y equals negative 1/2 x plus 2. What's my slope? Negative 1 over 2. What is my y-intercept known as b? 2. This is in the form y equals mx plus b. But to be able to graph it, I go to my y-intercept, which is 2. 1, 2, put a dot there. And then what is my slope? My slope is rise, it's negative 1/2. I got to rise -1, run 2. How do I rise -1? I'm going to go down 1, and then I'm going to run. That'll be to the right 2. 1, 2, put a dot. And then I get to put more dots if I want to. I rise another -1, run 2, 1, 2. Rise -1, run 2, 1, 2. And you notice this is lining up on a line. And then I do the best I can without a straight edge, connect my dots. And you notice it's a line going down, as I read it from left to right. It is a negative slope, which is exactly what it matches up to be. Does that make sense? What about this one? 12x minus 4y equals 16. Now, if I want to graph a particular equation, I got to put it in slope-intercept form, which means I want to solve it for y first. Again, most students will mess this stuff up because they're in too much of a rush to outthink the question. When I want to find the equation of a line, point slope. When I want to graph or read off the equation of a line, slope-intercept form. Each different form has a particular purpose. Does that make sense? So I'm going to take this equation and solve for y. Solving for y, I would subtract 12x from both sides. This gives me negative 4y equals negative 12x plus 16. Now solving for y, I would divide each term by negative 4. What I do to one side, I do to the other. What I do to one term, I do to all terms. This gives me y equals negative 12 divided by negative 4 is a positive 3x. A positive 16 divided by negative 4 is negative 4. 16 divided by negative 4 is negative 4. Now I've got it in the form, slope-intercept form of y equals 3x minus 4. My slope is 3. My y-intercept is negative 4. So it goes through the graph 0, negative 4. My y-intercept, 0, negative 4. 1, 2, 3, 4 right there. There's 0, negative 4. There, plot that point. And then my slope is 3, or better yet, 3 over 1. I need to rise 3. It's a positive 3. Run 1. Rise 3. 1, 2, 3. Run 1. Rise 3. 1, 2, 3. Run 1. Rise 3. 1, 2, 3. Run 1. And there, as I connect my line dot, is my equation of my line. Does that make sense? Questions? So the important aspect of this whole chapter is all the different forms of a line and what purpose they have and when to use what. All right. Since this is a wee bit of a review, because I know you've all been beaten up with lines in Algebra 1 and Algebra 2, and probably some of you guys even took Algebra 3 or pre-calculus or whatever in high school. Here's the deal. Tell me what you guys know about parallel lines versus what you know about perpendicular lines. Parallel lines have what? Same slope. Parallel lines are two lines that run congruent to one another, equal distance from one another, and the slope tells you how they, basically what direction they go. Parallel lines go in the same direction. Quote, parallel lines have the same slope. Two lines are parallel if and only if they have, quote, the same slope. So if you got two equations, y1 equals m1x plus b1, and y2 equals m2x plus b2, well, here's the deal. The b's may be different, but the slopes have to be parallel, have to be equal to each other. Okay? Okay, so, quote, take a look at this example. Find the equation of a line, if any, that is parallel to the line. And I've got this one. Y equals 1/2 x plus 6. I want to know what the equation of all the different parallel lines look like. Well, look at this form. Y equals 1/2 x plus 6. It's in the famous y equals mx plus b format. What is my slope? You can read it right off. What is it? 1/2. Okay? So, to find the parallel lines, it is any equation of a line that has a slope of 1/2. So I have y equals 1/2 x plus b, where b could be any real number. Now, there's a little trick to this one. B can be any real number. So I could have y equals 1/2 x plus 1, y equals 1/2 x plus 2, y equals 1/2 x plus 3. All these lines would be parallel to the line y equals 1/2 x plus 6. However, what if b was equal to 6? Are they going to be parallel? They actually would be the exact same line. So that's even more, I mean, they're not just parallel, they're the exact same line. So being the exact same line, I wanted a different line, so b could be any real number except b couldn't be -6 because that would actually make it, I'm sorry, +6. B couldn't be +6 because that would actually make it the exact same line.
So is that what you would write?
Yes.
I didn't know if there was like a certain format you wanted it in.
No, basically, this is the format that you want. What is the line going to look like? It's going to look exactly the same except for where your y-intercept is. It's going to be any constant that you can come up with. But if you did put 6 in it, but in the same line that you started with, so that's not really parallel, that's the same line. What about this one? 6x minus 3y equals 6. Okay? So here, I'm going to solve it for y, because I got to figure out what the slope is if I'm talking about parallel lines. So I'm going to subtract 6x from both sides. This cancels, that gives me -3y equals -6x plus 6. Then I'm going to divide by -3 on all sides. What I do to one side, I do to the other. What I do to one term, I do to all terms. That gives me y equals, what is -6x divided by -3? What's -6 divided by -3? Positive 2x. 6 divided by -3, a positive 6 divided by -3 is a -2. So what is my slope in this equation? 2. What would the parallel lines equation look like?
Y equals 2x plus b.
Y equals 2x plus b, where b could be,
Any number except -2.
b could be any real number except -2. Because if it was -2, then it would have been the exact same equation. Does that make sense? Parallel lines have the same slope, but you have to put it in slope-intercept form to check to see if they have the, quote, same slope. All right, so here is a classic question right here. Find the equation of a line that is parallel to the line, and they try to mess you up on this one, so don't freak out. 2 times y minus 1 plus x plus 3 all over 5 equals -7, passing through the point -5, 0. All right, first off, let's do this. What is the first 6 words of this question? Find the equation of a line. When you hear those magic words, find the equation of a line. What you're going to use every time? Point slope. Good, you've been programmed. Outstanding. Point slope. Y minus y1 equals m times x minus x1. To be able to use the point slope form, you're going to have 2 things. What are these 2 things you're going to have to use the point slope formula? For math people, so don't think too deep in this. A point and a slope. What's that sucker right there? -5, 0. That's my point. I'm half done now. Now I need the slope. So here we go. You see this equation? I'm going to clean it up. How would you clean it up? Well, the first thing I would do is distribute to get rid of my parentheses. This will give me 2y minus 2 plus x plus 3 divided by 5 equals -7. How many terms do you have written here? Just tell me one straight question. How many terms do you see? Terms are separated by addition and subtraction in the whole big scheme of things. How many terms? Addition, subtraction, and of course equals, goes without saying. There are 4 of them. 1, 2, this is one big term, 3, and on the other side equal 4. What you want to do is when you got weird fractions, get rid of weird fractions. This is what you learned about equations. What you do to one side, you do to the other. What I do to one term, I do to all terms. So my next move would be multiply by 5. Multiply everything by 5. So the first term would be multiplied by 5, the next one would be multiplied by 5, the third term would be multiplied by 5, and the last term would be multiplied by 5. What is 2y times 5? 10y minus, what's 2 times 5? 10. What is x plus 3 divided by 5 times 5? The 5's canceled, that's the whole purpose. Plus x plus 3 equals negative 7 times 5 is negative 35. Once you clear fractions, you will feel a lot better about your life and this class in general. Get rid of fractions, less chance for screwing it up. Now, here we go. Solve it for y. If I'm going to solve for y, I combine like terms. This is 10y plus x. What's minus 10 plus 3? Minus 7 equals negative 35. I would add 7 to both sides. This gives me 10y plus x equals negative 35 plus 7 is a negative 28. Solving for y, I would subtract x from both sides. This gives me 10y equals negative x minus 28. And what is the last move I'm going to make to solve for y? Divide by 10. What I do to one side, I do the other. What I do to one term, I do to all terms. So this gives me y equals negative 1/10 x minus 28 divided by 10. I can reduce that by 2. What is that? 14/5. There it is. All right. Oh yeah, what was the question? Oh yeah, I remember now. Find the equation of a line that is parallel to this line and going through this point. Being parallel, what is my slope on this equation right here? It's the coefficient in front of the x, which is what? Negative 1/10. Now here's the international symbol. M with the little parallel lines as a subscript. That means my parallel slope. But parallel lines have what? The same slope. So what's my parallel slope going to be? Negative 1/10. There's my slope, and there's my point. Now I can finish up this problem because I've got the point slope. Plug it in. Y minus my y coordinate, which is 0, equals my slope, which was negative 1/10, times x minus my x coordinate, which is negative 5. Notice when I'm doing these problems, I'm trying to help you guys out. Where most students messed up on the last test, for most students, their biggest problem was careless errors. They run through the stuff so quickly, 3 plus 3, what is that, 9? And run crap like that. And then they end up wondering why they got the problem wrong. So be careful, take your time. I'm going to solve this thing for y just to make them look good, and I'm going to put it in slope-intercept form. So y minus 0 is y, equals, I'm going to distribute. This would be negative 1/10 x, negative 1/10, a minus makes it a plus. Negative 1/10 times a positive 5 would make it a minus 1/2. It's 5 over 10, which reduces to 1 over 2. There's the equation of a line that actually goes through the point negative 5, 0, and it's actually parallel to this weird form of an equation of a line here. Does that make sense? Well, parallel lines have the same slope. What do perpendicular lines have? Opposite reciprocal or negative reciprocal. You flip the fraction and change your sign. Negative reciprocal, opposite reciprocal slopes. So here we go. So, slopes of perpendicular lines. I have here y1, this is your first equation. y1 equals m1x plus b1, and y2 equals m2x plus b2, where m1 and m2 are my slopes. Now, if these slopes were perpendicular, the international symbol for perpendicular is an upside down T. The fancy word for perpendicular means they meet at right angles, 90-degree angles. If you want to get into the high-level math, another word for perpendicular is the word orthogonal. Orthogonal, perpendicular, meeting at right angles, all means the same thing. Okay? So we have fancy words for this stuff too, but the basic term is perpendicular. Perpendicular lines are lines that meet at a right angle, a 90-degree angle. All right. And how you tell is they're negative reciprocal slopes. The slope of one will be equal to negative 1 over the slope of the other one. Basically, negative reciprocal slopes. If you got one slope, you flip the fraction and change your sign, and that's the slope of the perpendicular line. Negative reciprocal slopes. So, Find the equation of a line, if any, that is perpendicular to the line y equals 1/2 x plus 6. Well, what's my slope of y equals 1/2 x plus 6? 1/2. What would my perpendicular slope be? Perpendicular slope is flip the fraction and change the sign. This is a positive 1/2, right? So when I flip the fraction, what do I get? Negative 2 over 1, change the sign and flip the fraction, which is negative 2. So putting it in the famous slope-intercept form, y equals mx plus b, that would be y equals negative 2x plus b, where b is any real number except 6. Because if it was 6, well, actually, any real number, it can be 6 as well. Now you can include 6 as well. You don't have to accept any real number, period. Because with parallel lines, when you had the exact same y-intercept, it actually was the same line. These will never be the same line because they're going to be at 90-degree angles to one another. They could have the same y-intercept. They just meet up at the y-intercept. That's okay. So b would be any real number on this thing. Does that make sense? What about this guy? 6x minus 3y equals 6. Before you figure out the perpendicular aspect of it, you've got to find its slope. So to find the slope, you want to put it in y equals mx plus b format. So solving for y, I would subtract 6x from both sides. This cancels. Negative 3y equals negative 6x plus 6. Then I would divide each side and each term by negative 3. And that gives me y equals, what is negative 6 divided by negative 3? 2x, and 6 divided by negative 3 is a minus 2. What's my slope for this line? 2. What would my perpendicular slope be? Right, make it a fraction, 2 over 1, flip the fraction and change the sign. It would be negative 1/2. Negative reciprocal. So the line would be y equals mx plus b. So any line would be y equals negative 1/2 x plus b, where b is any real number. And then remember, with this stuff, you can actually have the same y-intercept. Find the equation of a line that is perpendicular to the line 2 times y plus x minus 3 times x minus y equals negative 9, passing through the point 2, 5. All right. First thing, what's these words right here? Find the equation of the line. That means anybody use the point slope formula. Y minus y1 equals m times x minus x1. I'm going to have two things to use the point slope formula, which is a point, which is right there, and I need a slope. So I'm going to sit there and solve for y on this equation. They love to give you stuff that works your algebra skills. So the first thing I would do is distribute to get rid of my parentheses. This would be 2y plus 2x minus 3x plus 3y equals negative 9. When I distribute, distributing the 2 gives me 2y plus 2x. When I distribute a negative 3, that's negative 3x, but a negative 3 times a negative y makes it a plus 3y. Combine like terms, what's 2y plus 3y? 5y. Combine like terms, what is 2x minus 3x? Minus x equals negative 9. Solving for y, I would add x to both sides. That gives me 5y equals, this cancels, x minus 9. Last thing I'm going to do is solve for y. So I'm going to divide both sides by 5. And when I do to one term, I do to all terms. All terms get divided by 5. And then pulling out my constant out front, y equals 1/5 x minus 9/5. What is my slope? That's what I care about. 1/5. You can read it right off in the famous y equals mx plus b format. So if my slope is equal to 1/5, and they mention the word perpendicular, what is my perpendicular slope? And that's the famous notation, m with an upside down t, perpendicular, what would it be? flip the fraction and change the sign, negative 5. It would be officially negative 5 over 1 when you flip the fraction, 5 over 1 and then change the sign negative, which is just pretty much negative 5. And there it is. Point slope formula. Plug it in. Y minus my y coordinate, which is 5, is equal to my slope, which is negative 5 for the perpendicular part, times x minus the x coordinate, which is 2. You'll notice when I plug in my points, I only plug it in for the subscripts. I'm going to clean this up and again put it in the famous slope-intercept form. I'm going to solve it for y. I'm going to distribute the negative 5. Y minus 5 equals negative 5x. Minus 5 times a negative 2 is a plus 10. I'm going to add 5 to both sides. And my final answer for my line is y equals negative 5x plus 15. There's the equation of a line that is perpendicular to this line passing through the point 25. Does that make sense? Did I lose you guys anywhere? Have you seen this stuff before? But has anybody ever kind of thrown it in your face about the 5 equationable lines and what each one's purpose in life is and when you use each one? Some teachers yes, some teachers no. And this is something that to me is vitally important. So whether I'm teaching college or actually working with some of the gifted and talented high school programs, I always put it in face. All right. The last little section, I just want to just discuss it just briefly, but this I got to pass back the test. So, is the equation of a circle. To have an equation of a circle, we have another standard formula, which is x minus h squared plus y minus k squared equals r squared. Where, when you're graphing a circle, you have the center, which is the point hk, and then you have r is the radius. So the center is the point hk, and r is the radius. What is a radius? It sticks out from the center the same distance, r, all the way around. And when you do that, you get an equation of a circle. So this is the standard form of equation of a circle. But here's the big deal. Inside the parentheses, you see a minus h minus k. Inside the parentheses, when you want to read off the data, you take the opposite. So look at this equation, and I'll do more of it next time, but this is the bigger equation. X minus 4 squared plus y plus 7 squared equals 1. What would the center be? Remember, the h comes off this guy, but it's inside the parentheses. You take the opposite sign. I see a minus 4, so what's my h coordinate? 4. I see a plus 7, so what is my k coordinate? Negative 7. This is my center. And the r squared equals 1. Take the square root of both sides. It's a distance. R equals 1. So this is my center. 4, negative 7. The radius is 1. And the reason why you take the opposite sign is, what makes this section, this term, x minus 4 squared, what makes it 0? What x value makes this thing 0? 4. What y value makes y plus 7 squared 0? That's really where it's coming from. But the pattern is take the opposite sign inside parentheses. We'll talk more about this next time. So the last thing I'm going to do today in the last 4 minutes I have in class is to pass out the test. So let me do that.